All right, this is your stat sensei, Mr. Spensei, and we're looking at the 2002 question 3 problem. This one deals with the normal distribution and combining random variables. So there are 4 runners on the new high school team. The team is planning to participate in a race in which each runner runs a mile. The team time is the sum of the individual times for the 4 runners. Assume that the individual times of the 4 runners are all independent. This will be important. We'll talk about this in a moment. Each other. The individual times in minutes of the runners is similar. Races are approximately normally distributed. That lets me go, oh, if they say normal, I'm probably working with the normal, which and here are the means and standard deviations. Okay, runner 3 thinks that he can run a mile in less than 4.2 minutes in the next race. Is this likely to happen? Well, they've already told us that we're working with a normal distribution. And in this case, we have a mean of 4.5 for this runner. And we have a standard deviation of this runner of 0.14. So we want the probability that X is less than 4.2, where X is the runner's time. It's actually runner's 3 time, but runner's time. So we draw out a normal distribution, and we sit there and go, okay, this is at 4.5. And we're going to mark off, and we sit there and go, he wants to be 4.2 or less. Standard deviation happens to be 0.14. So we notice that he's a ways away. So we want the probability that Z is less than, because this is going to be Z equals X minus mu over sigma, probability that Z is less than 4.2 minus the 4.5 over the standard deviation of 0.14. So I'm going to go to stats test, stats, arrow over to test, Z test. My mean is 4.5. My standard deviation, they said, was 0.14. We're looking for an X. Really, we're looking for an X of 4.2. I should write that over here. X equals 4.2. And whenever we do a problem like this, our N is 1 because it's one race. And we wanted a less than, and we calculate. So the probability that Z is less than negative 2.1428 equals 0.0160. All right, so there's our probability. So that takes care of the first part, part A. And then it says, is this likely to happen? So I have to answer the question. I can't just stop there. And it's like, no, this is unlikely to happen. There is less than a 2% chance of runner 3 running a time of 4.2 minutes or less. All right. It's not impossible, but unlikely. All right. The distribution of possible team times is also approximately normal. what are the mean and standard deviation of the distribution? Well, means, regardless of, we can always add means. So basically in this case, we can go, well, mean of 1 plus the mean of 2 plus the mean of 3 plus the mean of 4, which would be 4.9 plus 4.7 plus 4.5 plus 4.8 equals, we add all those up and we end up adding those up and we get 18.9. Didn't mean to switch colors on you, but sorry about that, I did. Then they asked for the standard deviation. All right, so a couple things. To add standard deviations, they must be independent. And then the other thing is we can't really add them directly. So we're going to have the standard deviation of runner 1 plus the standard deviation of runner 2. So we're looking for the standard deviation of 1 plus 2 plus 3 plus 4. That's what we're looking for. And that equals 0.15 squared plus 0.16 squared plus 0.14 squared plus 0.15 squared. All of that under the radical. 0.16 squared. Oops. 0.15 squared plus 0.16 squared plus 0.14 squared plus 0.15 squared. We end up getting 0.0902. And I'm just going to take my value and raise it to the half power. And I get 0.3003. All right, suppose the team's best time to date is 18.4 minutes. So their best time is 18.4, but we expect them to run at 18.9. What's the probability the team will beat its own best time? So once again, because of part B, we know we're working with a normal. So we have a normal. Our mean happens to be 18.9. And our standard deviation is 0.3003. And we have an X of 18.4. So we want the probability that X is less than 18.4, where X is the team's time. And what this is going to look like is this set up just like this, with a mean of 18.9, a standard deviation of 18.4. This goes to negative infinity. This is 0.3003. So Z equals X minus mu over sigma. We want the probability that Z is less than 18.4 minus 18.9 divided by 0.3003. Stat test, Z test. Mean 18.9, standard deviation 0.3003, X of 18.4, N is 1. We want to be less than that because we want to beat the time. And we want the probability that Z is less than negative 1.6650, which equals 0.0479. All right. And there's that from the calculator. And there's my value. And if you showed all of that which isn't too horrible. That's a pretty good chance of getting all credit on that. The key thing is to remember to square your standard deviations before you sum them and then take the square root of them. Also, please make sure that you're drawing pictures and labeling things. It makes really a big difference in how you perform. Hope this helped a lot, and I'll see you in the next one.